Now let's tackle actual programming. First, for running the program, let's start Terminal in your dock menu. As usual, let us use ls command to see the items in the current folder. Here you see the folder cs exists, so let's go into it by typing cd space cs. Again, ls to check what's inside. You should have the folder proj3. So let's go into this proj3 by cd space proj3. And then again ls to check what's inside. Two files like this, right? This time, let us consider divloop.rb. Now, let's execute it by ruby space divloop.rb. Then it's waiting for us to give a number for the variable d, which is used as a divisor for calculating 1 over d. So let's type 4, for example. Then it calculates 1 over 4 like this. Okay. As we studied in the previous session, these are the result of the division. More specifically, the left column, these numbers, show the quotients after the decimal point. So these 2 and 5 should be interpreted as 0.25. That is, 0.25 is the result of 1 over 4. On the other hand, these values are the remainders obtained at each division step. For example, by dividing 10 by 4, we get a quotient 2 and remainder 2. Then, by dividing 20 by 4, we get quotient 5 and remainder 0, which terminates the division. Now, let's try it with another divisor. Okay, and then type 7. You see, the computation continues. Let's stop it. Hope you remember how to stop this infinite computation. Yes, by pushing both Control key and C at the same time, right? It stops. Let me try it again and stops a bit quickly. So 7. Okay. It shows the first several steps of the division. As you see, we have 0.1428571, blah, blah, blah. Okay? So the recurring occurs from this one. We would like to stop the computation at this point. For our later consideration, let's see when should we stop the division. Is it when we get the same quotient, like 1 in this case? To see this, let's try it with yet another divisor. How about giving 17? Okay, 17. Okay, let's stop it. These are results. As before, the numbers in the left columns are quotients. Note that some quotients have been repeated. For example, these occurrences of 8 or these 2's, right? But as you see, the recurrence takes place here, from here, 0, 5, 8, 8, 2, 3, okay, are repeated from here, okay? The same sequence is repeated from here. This means the same quotient does not necessarily mean the start of recurring. Then when? Let's look at the remainder, the numbers of the right column. Okay. These are remainders at each step of the division. You see, these remainders are all different, and here we have the same remainder, 10. Okay, the same one, 10. Okay, that appeared before. Then, as you see, the recurring starts from here. Well, if you consider a bit more, this is reasonable. The remainder is the next dividend. More precisely, the next dividend is the remainder multiplied by 10. So the occurrence of the same remainder means that the process of division comes back to the same situation. Let me point out here that this division has started from dividing 1 by 17. So this dividend, or numerator 1, is regarded as the first remainder. In fact, the first step of the division is to divide 1 times 10 by 17, which gives the quotient 0 and the remainder 10. This same situation occurs at this point, right? Here we have the remainder 1. And the next step is to divide 1 times 10 by 17, resulting the quotient 0 and the remainder 10. So the real starting point of the repetition is at the point when we had the remainder 1, which can be interpreted as the first occurrence of the same remainder by regarding this initial dividend as the first remainder. You may think that having the remainder 1 is only the timing when the repetition starts and the recurring occurs. Is it so? Let's try one more example. This time, let's use 24 for D. 24. Then you see the recurring starts when 16 appears second time as the remainder. This is the point. It may not be easy to predict which number appears as the remainder more than once for the first time. So the easiest solution is to remember which number has appeared as the remainder and to check whether the newly obtained remainder has not appeared yet during the computation. If it is one of those previous remainders, then we stop the computation. Keeping this observation in our mind, let's see the program. To modify the program, divloop.rb, let's activate the code editor. Okay. And now, under the File menu, open. Then we have this PROJ3. Okay. If it doesn't, click the Home icon, and then double-click CS, and then double-click PROJ3. Okay. The file names would show up. And let's open the divloop.rb. This is the whole program. Although we explained it in the previous session, let me go through it quickly, explaining the key points. First, this is the part for getting the input, that is the denominator D. For example, by typing 7, the number 7 is stored in the variable D, okay, which is used as the divisor. The main computation is done in this part. Here, there are two important variables. The variable x is used to keep the remainder that is just obtained, which is in fact the next dividend. Initially, it is set to 1 here because we are going to compute 1 divided by D, as we discussed. This could be considered as the first remainder. The variable stop is used to remember the status of whether the calculation should be stopped or not. More specifically, we use the variable stop here in the condition of this while loop. This condition says that if stop is not equal to 1, then the next round of the while loop is executed. Otherwise, if it is 1, then this while loop is terminated, which is in fact the end of the whole computation. So initially, we set the variable stop 0. Now let's see the inside of this while loop. Here, one step of the division is conducted. Okay. For this, first, the value of x is multiplied by 10, and then in the second line, the quotient of x divided by d is computed and stored into variable q. Then, here, the remainder of this division is computed and stored into the variable x as the new remainder. We use this print command to show the values of q and x. Finally, we set 1 to stop if the remainder is 0. This is the outline of this program. What we want is to check whether the obtained remainder, which is stored in x, has been appeared before. One important hint given in the previous session is to use the array T. We use array T to remember which numbers appeared as the remainder. So activate this statement. Okay. And another important hint may be its size. We only need D boxes, okay, for this array, whose indices are from 0 to D minus 1. How shall we remember the new obtained remainder? Please consider it a bit. I will give one of the answers in the next session.